and welcome to this module on AI versus ML versus DL. Let's understand the difference between artificial intelligence, machine learning, and deep learning with some simple examples. Let's start with artificial intelligence, or AI. Imagine a self-driving car that can make decisions like a human driver, such as navigating traffic or detecting pedestrians, and making safe lane changes. AI refers to the broader concept of creating machines or systems that can perform tasks that typically require human intelligence. Next, we have machine learning, or ML. Visualize a spam email filter that learns to identify and move spam emails to the spam folder, and that's based on the user's interaction and email content. Now, ML is a subset of AI that focuses on the development of algorithms that enable machines to learn from and make predictions or decisions based on data. To understand what an algorithm is in the context of machine learning, it refers to a specific set of rules, mathematical equations, or procedures that the machine learning model follows to learn from data and make predictions on. And finally, we have deep learning, or DL. Think of an image recognition software that can identify specific objects or animals within images, such as recognizing cats in photos on the internet. DL is a subfield of ML that uses neural networks with many layers, deep neural networks, to learn and make sense of complex patterns in data. There are several types of machine learning, including supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, where the algorithm learns from labeled data, making predictions or classifications. Unsupervised learning is an algorithm that discovers patterns and structures in unlabeled data, such as clustering or dimensionality reduction. And then you have reinforcement learning, where agents learn to make predictions and decisions by interacting with an environment and receiving rewards or punishments. Let's understand the supervised machine learning algorithm. Let's take an example of how a credit card company would approve a credit card. Once the application and documents are submitted, a verification is done, followed by a credit score check and another 10 to 15 days for approval. And how is this done? Sometimes purely manually, or by using a rules engine where you can build rules, give new data, get a decision. The drawbacks are slow. You need skilled people to build and update rules, and the rules keep changing. The good thing is that the businesses had a lot of insight as to how the decisions were made. Can we build rules by looking at the past data? Let's take a look. We all learn by examples. Past data is nothing but a set of examples. Maybe reviewing past credit card approval history can help. Through a process of training, a model can be built that will have a specific intelligence to do a specific task. The heart of training a model is an algorithm that incrementally updates the model by looking at the data samples one by one. And once it's built, the model can be used to predict an outcome on a new data. We can train the algorithm with credit card approval history to decide whether to approve a new credit card. And this is what we call supervised machine learning. It's learning from labeled data. And we're going to talk more about this in the next module. Now let's understand the unsupervised machine learning algorithm. Data does not have a specific outcome or a label as we know it, and sometimes we want to discover trends that the data has for potential insights. Similar data can be grouped into clusters. For example, retail marketing and sales. A retail company may collect information like household size, income, location, and occupation so that the suitable clusters could be identified, like a small family or a high spender, and so on. And that data can be used for marketing and sales purposes. Regulating streaming services. A streaming service may collect information like viewing sessions, minutes per session, number of unique shows watched, and so on. That can be used to regulate streaming services. Let's look at another example. We all know that fruits and vegetables have different nutritional elements. But do we know which of those fruits and vegetables are similar nutritionally? For that, we'll try to cluster fruits and vegetables' nutritional data and try to get some insights into it. This will help us include nutritionally different fruits and vegetables into our daily diets. Exploring patterns in data and grouping similar data into clusters drives unsupervised machine learning. Let's understand the reinforcement learning algorithm. How do we learn to play a game, say chess? We'll make a move or a decision, check to see if it's the right move or feedback, and we'll keep the outcomes in your memory for the next step you take, which is learning. Reinforcement learning is a machine learning approach where a computer program learns to make decisions by trying different actions and receiving feedback. It teaches agents how to solve tasks by trial and error. This approach is used in autonomous car driving and robots as well. Deep learning is all about extracting features and rules from data. Can we identify if an image is a cat or a dog by looking at just one pixel? Can we write rules to identify a cat or a dog in an image? Can the features and rules be extracted from the raw data, in this case pixels? Deep learning is really useful in this situation. It's a special kind of machine learning that trains super smart computer networks with lots of layers. And these networks can learn things all by themselves from pictures, like figuring out if a picture is a cat or a dog. Let's explore what neural networks are. To make tricky things work, we use layers of neurons. Neural networks are like a bunch of connected brain cells stacked together. They're an example of a supervised machine learning algorithm that is perhaps the best understood in the context of functional approximation. Functional approximation involves estimating a hidden function by examining past or currently known data from the specific domain. Generative AI, a subset of machine learning, creates diverse content like text, audio, images, and more. These models, often powered by neural networks, learn patterns from existing data to craft fresh and creative output. For instance, ChatGPT generates text-based responses by understanding patterns in text data that it's been trained on. Generative AI plays a vital role in various AI tasks requiring content creation and innovation.